Hey everyone, welcome back. Hope you're all still doing well. We are officially only have a couple weeks left of new lessons. So time kind of flew by here. We in the last week or so of June, we're going to be doing some finals review. So really, we only have a few weeks left of new material. So almost there. Um, our essential question today is using the first fundamental theorem of calculus with functions involving trig, and then your exit ticket's going to be a handful of problems out of your book. As usual, just taking a picture and uploading them to Google Classroom. Let me know if you need any help on that. Okay? So before we do any integration, definite integration with trig, we have to remember um, a small set of things. Okay, so one is trig integrals. Okay, so I have a list here of trig derivatives, which we learned in first trimester. I have a list of trig integrals, which you're going to need today. And if you haven't written these down earlier in your notes, or if you just want to pause the video and copy them down again just so you have them fresh, these are trig integrals, I should say. Okay, so I'm going to keep those handy because I'm going to come back to those during our examples. Another couple sets of tools that you need for today, two extra things are the unit circle. And no, you don't have to memorize the unit circle since you're at home. Obviously, you can get this anywhere, even just Google search of a unit circle will bring this up. But you need to know the different points on the unit circle as well as the coordinate points that go along with it. Okay. You should also know that cosine corresponds with all of your x values. You should know that sine corresponds with all of your y values, and tangent corresponds with y over x. Okay, so you would have learned that in pre-calc. I know we probably talked about it a little bit also first trimester, but that's also something that we're going to go through today. Also, we haven't used these yet up to this point. I mean, we may have used it a little bit, but these need to come back today. These are Pythagorean identities. Okay, so again, just hopefully remembering from pre-calc, maybe they look familiar. Sine squared plus cosine squared is 1, and then you got the next 2 under it. Those are things that we're going to need today. Okay, so if you have those three things, you have the trig integrals, you have the unit circle, and you have the Pythagorean identities. Those are the three tools you need to get through your set of problems today. And I'll do 3 examples with you, just kind of using one tool on each example. Okay, and these will match what a lot of your assignment looks like today. Okay, so let's start with the integral, the definite integral of 0 to pi of 3 plus sine x. Okay, so just looking at this, you can just take the integral straight up of this one. There's no there's nothing really you need to convert with the identities here or anything like that. We know that the integral of sine x, if I were to go back to that page, the integral of sine x is negative cosine x. We know how to take the integral of 3, so we can just do this right out of the gate here. So that's going to be equal to 3x, right? Because the integral of 3 is 3x. Remember, if I go backwards, the derivative of 3x would just be 3, so that's how I check myself. Integral of sine x is negative cosine x. So I'm going to say minus cosine x. And then just like last week, we have our boundaries, right? We're going from 0 to pi, so that's where we need to evaluate it. So just like last week, it's no different. We're just going to take our boundaries and plug it in. So for pi, I'm going to say 3 pi minus cosine pi. Okay, so that takes care of pi. I plugged it into both of these. Minus, now I need to go to 0. So I'm going to say 3 times 0 minus cosine times 0. So I plugged in my pi, plugged in my 0, and I'm subtracting the 2 and see what I get. Okay, so 3 pi, we're just going to leave this as an exact answer in terms of pi. So 3 pi is just 3 pi. Okay, let's see what we have. Cosine pi. Okay, so let's take a look back. Hopefully, if you guys could, whether print one out or pause this video and pull up the unit circle on Google, but just know that cosine pi, on a lot of these, you're going to have to look at the unit circle. So let's find pi on our unit circle, which is right here. The cosine value of pi, which is the x value, and again, just like I said before, I'll just write this off to the side. The cosine, oops, let me rewrite this. The cosine values correspond with your x's, the x coordinates. The sine values correspond with your y coordinates, and your tangent values correspond with y over x. Okay, so we're looking for cosine pi, which is -1. So minus a negative is a +1. Okay, minus 3 times 0 is 0. Cosine 0, okay, let's go back to our unit circle. Our x value at 0 is 1, so -1, okay? So what this really turns into is 3 pi plus 1, and then we've got, if I distribute this minus sign, minus a negative would be +1. So it's going to come out to 3 pi plus 2. Okay, there's no further I can go with that. That's my final answer. Okay? All right, let's go to the next one. So we're going to, again, use all of our tools here. This one is the integral from 0 to pi over 2 of cosecant squared over 1 plus cotangent squared. All right? So first thing I usually do is, on all of these problems, just look at your integrals. Okay, so again, in my numerator, I have cosecant squared. Well, let's see if there's a cosecant squared anywhere in our integrals. And cosecant squared at the bottom, okay, possibly I could use this one, right? But then let's look at the denominator, 1 plus cotangent squared. That doesn't show up, 1 plus cotangent squared doesn't show up in any of our integrals. Either way, we haven't never talked about taking an integral when you're dividing. So it's not like we can just get a quick, easy answer from this. So what I'm going to do is then, if I can't use my integrals right away, let's look at, for example, 1 plus cotangent squared. That can be converted using your Pythagorean identities. 1 plus cotangent squared is equal to cosecant squared. Okay, so again, these are going to be your friend on a couple of these problems today. So I'm going to rewrite this as the integral of 0 to pi over 2 of cosecant squared theta over, now let's convert this, 1 plus cotangent squared is cosecant squared theta d theta, basically in terms of theta, okay? This helps because now we don't have to divide anymore. So again, we haven't talked about division with integrals, so we wouldn't have been able to do this anyway. So what I do know is that this simplifies to 1. Okay, so I can rewrite this as 0 to pi over 2 integral of 1 d theta. Okay, well, we're ready to take the integral now. So the integral of 1 is just theta. So just, if the theta is throwing you off, just think of it as x. The derivative, or the integral of 1 would be 1x. So the integral of 1 in terms of theta would be 1 theta. So this is just theta. And our boundaries are 0 to pi over 2. Okay, so when I plug in my boundaries, if I plug in pi over 2, I get pi over 2. Minus, if I plug in 0, I get 0. So my answer is just pi over 2. Okay, so just to recap, I have 1 plus cotangent, I changed it to cosecant squared. That allowed me to simplify this fraction to just be 1. Okay, the integral of 1 d theta is just theta. Okay, then I took my boundaries, plugged them in, and got my pi over 2. Okay, all right, let's try one last one. This one's going to be 3 cosecant cotangent from negative pi over 6 to pi over 6. Again, the first thing I always do is look at my trig identities and say, okay, I don't have any fractions here that I have to worry about, so that's good. So let's just look at our trig identities, and we're looking for cosecant cotangent, and cosecant cotangent shows up right here. okay, which is equal to negative cosecant. When I take the integral, it'd be equal to negative cosecant x, okay? One thing that I should have said at the start here is whenever you have a constant, please don't forget that property that we talked about last week that allows us to pull the constant out of the integral. So I can rewrite this as such. Okay, so all I did was rewrite it to pull my constant out. Whenever you have a constant in your assignment today, please pull it out because that's going to help you, okay? So now, integral of cosecant cotangent we said was negative cosecant. So this is going to be equal to 3 times negative cosecant x. And I think that was it, right? And then, so then we're going to go from pi over 6 to negative pi over 6, okay? Now, when we evaluate this, when we plug it in, it's going to look like this. I'm going to have 3 times negative cosecant pi over 6 minus 3 negative cosecant negative pi over 6. Okay, well, how do we evaluate this? So we have pi over 6. What we're going to have to do in order to get our value at pi over 6, just like we did on our first problem, or any of these problems really, is we have to look at our unit circle. Okay, so pi over 6 is right here. And remember, sine is your y values. Cosine is your x values. Okay, but we're not looking for sine or cosine. We're looking for cosecant. Okay, so please remember that cosecant is the reciprocal of sine. Okay, if you have to go back and refresh, what's the reciprocal of what? Again, that's a quick Google search that you can do, but cosecant is the opposite or the reciprocal of sine. So if sine is 1/2, then the reciprocal of that would be 2. So it would be 3 negative 2. Okay, minus 3, let's see what this ends up being. We want to go to negative pi over 6. Well, if this is positive pi over 6, the opposite direction would be negative pi over 6. So this point right here would be negative pi over 6. If I take this value, which is my y value because it's sine, and I flip it, it would be instead of negative 1/2, it would be negative 2. So the issue here is we already have a negative. So negative negative 2 is actually going to turn this to a positive. Okay, so what this becomes is negative 6, and then minus 3 times 2 is 6, is going to be negative 12. Okay, so we're at the end of our video here, but just to recap, when you get to the point where you have a trig function and a radian point, you want to look at your unit circle to figure out what value is that. At pi over 6, what is my value? Okay, you could do that for any value, pi over 2, pi over 3, pi, 0. You just have to look at your unit circle and see what your value is. Okay?